Okay. So I'm terribly sorry. There's probably going to be another intervention like that. I thought it didn't work. It worked from home. It didn't work today, though I'm from work. All right, let's continue. So fishing methods. Also, so per se nets really destructive. By the way, they can actually kill dolphins. Today they have what they call safe nets, but they have lower it in a certain place, and they basically let the dolphins escape. And you have a dolphin safe. They have a stamp on it for the tunas that you can find. And also spearfishing, very destructive because it's quite selective. Usually they catch the big ones, but it's time consuming. So there's not too much people that do spearfishing. It's only for a local. Poison, Rotanon, for instance, it's very effective, but it kills everything. It's so unselective. It's terrible, terrible. And it kills everything, not necessarily fish, everything that's alive. It's basically, you can put yourself asleep with it. It's like chloroform, for instance. So that's one thing. And you can do some blast fishing. And you can see blast fishing here, and which is very common, by the way, unfortunately, in rural areas, artisanal areas. And what they do is you can see exactly here in this guide, he's making this is how they do it. I'm not going to have time to show you this, but if you want to go in, you can see here in the clip how to do it. And you can see they take a bottle, and then they fill up with from matches, the top of the matches. You put it in, and then they basically use a smoke. They just light it up, throw it in, and boom. And what you get is everything around it gets killed. Mostly fish, by the way. So it's a little bit less selective. So, and this is how it looks like. And I've been diving some areas which they had been doing some blast fishing, and it looks much, much worse than this. It looks like basically rubble. There's nothing there. And you can see there used to be a thriving reef. It's just terrible.
Would you say that that's more destructive or less destructive than bottom trawling?
I would say it's less destructive because the scale is much smaller. But in some areas, they do it so much. And when I was diving, for instance, it was in Malaysia. I could hear the bombings. It was far away, but I could hear the explosion because it travels very nicely in the water. And I asked the locals, what is it? This is the blast fishing. They said, yeah, they still do blast fishing. And they're trying to change it. They're trying to tell them that even if they can make much more from tourism, much more money from tourism than from catching a few fish, which is obviously true.
Crazy.
All right. So here we go. So if I'm going to check out who's selective and non-selective and how destructive it is, you can see here by selectiveness, this is the size spectrum, and this is the catch by how non-selective is, by the size and by what they catch. So long lines, relatively specific. You have gill nets and tangling nets, which is basically similar to gill nets. Harpoons, obviously didn't talk about, but look, there's pelagic trawling, impersonates, very big and quite non-selective. But probably the worst ones are bottom trawlers. You can see demersal fish trawlers. It's pretty much the same as beam trawlers, and shrimp trawlers. The difference between these two, by the way, this is in shallower area usually, shrimp, and it doesn't have on the bottom. It has, instead of having wheels, has a chain, because the shrimp are found just underneath the surface, and the chain pretty much brings them up. They swim up, and then they get caught into the chain, into the net, and they don't catch too much. You want to see how much they catch? I'm going to show you. This is just a comic relief a little bit for your hard day of watching me. Okay. And I'm today a lot with Tom Hanks. I'm sorry, I didn't mention it. It was not intended. Right, you don't hear it, right?
Yeah, not yet.
How did I do it? That's the question. All right. Well, it's going to be sad if we're not going to see it. You guys are with me? I just want to know.
Yes.
Okay.
Yeah.
Here it is. Okay. So a little bit of Forrest Gump.
They're over there! Get on the wheel and take a left! Okay!
Creative yet contentious.
Stop! What are you doing? Take a left! Left! That's where we're gonna find those shrimp, my boy! Ah! That's where we'll find them!
Theoretically, every shareholder
Still no shrimp, Lieutenant Dang.
Okay, so I was wrong.
ownership should provide,
Well, how are we gonna find them?
or so
All
the
right.
theory goes.
So that was kind of a comic
Authors
relief.
Christopher Costello, Stephen Gaines, and John.
Sorry about this. I knew it's happening. All right, so we have Sam. Good.
A study published in the September 19th issue of Science
All right, so how do we do it? How do we catch? This is a worldwide. Most people do bottom trawls, purse seines, and small scale, which means the seine nets and so forth. You guys hear me, by the way? I'm not sure if you guys are with me.
Yes.
Yeah. It's clear, yeah.
Okay, wonderful. All right. And when you go to Israel, you can see that we use small scale and bottom trawlers, the two major ones, a little bit of purse seine nets. And so when we talk about this from a local point of view, we're different from the rest of the world, and also from the Mediterranean Sea. So most of what we catch is usually by gill nets. This is the most common way of doing it here in Israel. And bottom trawlers. And the interesting about bottom trawlers is that they've been decreased over the years. You can see here, this is from Israel. And you can see over years there's a decrease in the use of bottom trawlers. And even if you don't see the continuation here, this is just it's how much they catch. This is you can see eventually the fleet has been going down. You don't see the number of fleet, but you can see what they're catching. The catching has been going down, and the fleet has been decreased, by the way. So here you can see the freeze. It was freeze to 30, but today there's only six operating trawlers, and it's very problematic, by the way. I'm going to explain to you in a bit. The idea about is what you catch is important. You know that the amount of fish has been leveled out. So since the 1990s, so it's almost now 30 years that we don't see an increase in the amount of fish. And someone said it's because there's not enough fish. But the question is, are we doing enough to catch them? And the answer is yes. We're doing enough. Actually, we're doing more than we actually tried before. Because at the time, this is what they call the catch per unit effort. At the time, you didn't need to work too hard to catch fish. Today, in order to get the same amount of fish, you need to work harder, and you still get that same line. You don't see an increase in the amount of fish. That means you're working harder and you catch the same. So a catch per unit effort, it measures how much the relative abundance of how much catch you get. For instance, if the effort can be, it's various, okay? You can have, for instance, the number of anglers per trip, okay? And the catch rate is the estimated number of fish caught per angler. And eventually is the total number of fish caught per what you have here. So this is the CPU. So the total catch divided by the total effort. What you can see here, and this is an example for the Philippines, you can see a decline in the catch per unit effort. This is tons per horsepower, meaning how much you're working to get this. And you can see a huge decline in the CPU, catch per unit effort. So they're trying more and they're getting less. You can see decline catch per unit effort in W with fishermen. This is by traps. And you can see here hooks and lines. You can see that how much it is. And this is supposed to be for exactly the same catch per unit effort. You can see there's a decrease. The effort is remaining the same, the catch goes down. What you need to do is increase the effort in order to keep it. So how do we do that? That's your deal. The effort can be the number of traps, number of lines that you put, number of boats, how far you go, the engine capacity. You have better gear, more intelligence, more knowledge. You have planes going off. You have side scans. It becomes very, very technical to catch. And obviously you go to different areas in distribution of the sea. And also people talk to each other. They know if there's in one area, fishermen know there's a lot of catch for that area and know they're going to get away. They talk to each other, though they're not very nice to each other sometimes. They do talk to each other from time to time to catch more than they do. And they go to new areas to catch more fish. Now, what would happen if you do that? For instance, it's a catch per unit effort. And you can see this is the effort. If we increase the effort, what will happen to the catch? Guys, what do you know? What will happen to the catch?
It'll probably increase.
It will increase. Okay. That's the idea. It will increase. So the idea is if we increase the effort, we'll increase the catch. Now what happens is not exactly like this. And you can see what would happen if we increase the effort. You can see here, this is the catch with and without tunas. And you can see, although increasing the effort, it's still leveled off. And I'm telling you, you don't see it in the graph here, but the effort's been increasing all the time. So you can see an increase in effort here. And then here, from here on, there's an increase in effort, but the amount of catch is still relatively the same. The reason is what we call overfishing. And you can see here, this is an estimation of the biomass of fish next to the shelf, okay, the continental shelf. See, most of the fishing is done relatively close to land because two reasons. One, it's very close. And the second one is there's more fish, which we talked about in the beginning of the lecture. There's more fish in the shallow waters. So you go where there's fish. And this is 1900s. This is their estimation in the year 2000. It's gotten worse, by the way, since then. So today, when we talk about overfishing, we say that almost everywhere in the world it has been overfished. About 10% is underfished, meaning it's relatively fine. 61% fully fished, and about 30% overfished. And that means that there's a huge amount of pressure, ecological pressure, on the fish population worldwide. So what people do, they do what they call is fishing down the food web. So let's have a look at what the fishing down food web is. And I hope I have this. Sorry, this can be from here.
Anyone who goes fishing probably has a story about the one that got away. It was this.
It's the wrong one. Okay, this is the answer. Okay, so this is not the wrong. This is not the wrong. I'm gonna go back to it and explain to you this in a second. Where are we at? So I'm going to explain what fishing down the food web is. The fishing down the food web basically is what needs to be done in order for us to catch more fish. basically increasing the effort. Now, what they do is they call it fishing down fishing down the food web. Oh, I'm sorry. Okay, it is relative. I'm sorry. Is what people do is that they go and usually catch the big fish. And if you catch the big fish, eventually you're left out with smaller fish, and eventually with smaller and smaller fish. This is called fishing down the food web. This is a relatively known thing about Pauli that devised this theory. And the idea is that what happens is when you catch the big fish, that you have a very big problem with the reproduction of new fish. Since most of the fish that are big ones, they're the ones that are reproducing. If I catch the big ones, I won't have the ability to let others grow and reproduce. So I'm increasing eventually the number. I'm reducing the amount of damage to the fish population. And the question is it good? So what people do? What do you think? So how do you if you have what they call fishing down the food web, how do you control it? How can you keep it by?
For the species, you have a size limit, so it has to be over a certain size.
Exactly. Okay, so this is exactly what people are talking. So now I need to know is what I do. If the size is too big, too small. Sorry, if it's too big, I'm going to keep it in. So they have during seasons. They have usually during the reproductive season. They tell the fishermen not to fish from a certain size and on. The problem is that, first of all, it's very difficult to control it. And also, eventually, it doesn't work out over time. Now, what happened is eventually what people think about is, I'm going to show this in this really cute, what I wanted to show you before. Theory, how probably the best way of working it out is keeping the population without going down the food web. So let's make it bigger. Oh, the one that went away.
Anyone who goes fishing probably has a story about the one that got away. It was this big, don't you know? Yeah, that was a bummer. But it's actually quite important that big fish get away, both for fish and fishermen. For most of the species that we fish, commercial and recreational fishermen are only allowed to keep individuals above a minimum legal size. The idea behind these laws is to protect juveniles so they can grow big enough to reproduce at least once before becoming our dinner. In theory, that means there will always be enough fish for dinner tomorrow. And ensuring dinner for tomorrow is important enough that the English Parliament discussed protecting young, that is, small fish as early as 1376. And today it's a common regulation for fisheries worldwide. Except it doesn't really work. First, large individuals have the greatest number of successful offspring, both because bigger fish produce more eggs and because the eggs they produce also contain a more generous food supply for the baby fishies. So by removing the largest individuals of a given species, we severely decrease the population's ability to replenish itself. Second, if we only remove the largest fish, that means fish that are small for their age, and thus smaller when they first reproduce, are more likely to live long enough to make babies. So individuals with small fish genes tend to stay in the water, reproduce, and pass on their genes to new generations, while big fish and big fish genes become rarer and rarer. We're basically breeding smaller fish, unintentionally, and it's not a small change. Size-selective fishing has caused the body mass of large commercial fish to be cut in half over the last 40 years. Let me say that again. Heavily fished fish are now half the weight they used to be. 6-year-old haddock, for example, weigh 40% of what they did in 1970. Imagine if full-grown men weighed 65 pounds. Clearly, size-selective fishing means fewer and smaller fish in the water, which suggests it's not the best way to keep our fish supply stocked for future human generations. And in fact, there's a new idea called balanced harvesting ready to save the day. Instead of reeling in all the largest individuals, fishermen would catch a smaller number of fish across a wider range of sizes, keeping the numbers and sizes of fish, well, balanced. However, old habits die hard, and the use of size limits is deeply ingrained in our collective fisheries management DNA. But sooner rather than later, we'll have to accept that it's good to let some of the big ones get away, for only they can change the course of fishery.
So I hope you liked the fish story in the end. About prices, I see that someone wrote about, do you have an increase in the price of fish? Not necessarily, because you have aquaculture instead. So the aquaculture takes place instead of the fisheries, the regular fisheries, that is. All right, so we talked about fishing down the food web, and now I understand that if I take only the big ones, it's problematic for various reasons. But people starting going not only for bigger ones, they also go down deep. And the reason is that you can find more fish as you go deeper, because there's less in the shallow areas. And you can see what happened over time. You can see the pelagic ones up to the 1970s, and then mid 70s, then started collecting the bigger ones, I mean the deeper ones, the pelagic ones. Same for the bottom ones. And high seas, meaning out in the open, you can see that. So these two are high seas. This is actually the general of all of them together. You can see the mean depth of the catch has, over the years, gone deeper and deeper. So people now are fishing deeper. And when they fish deeper, that means they're trying to get more fish. And we know they're not getting more fish. So they're trying to basically, if the new the habitats, the old habitats has been depleted, they're going and harvesting new habitats. Okay, and if you look at it, look at this. The sad thing about this is if you go and you look at the life history of fish that live in the shallow areas, have their longevity, how long they live, is relatively short. Those that live deeper usually have a longer life expectancy. So what happens is, if you deplete the fish in the deep end, it will take him many more years to restore the community or the population. Like orange roughy, nobody knew about orange roughy about 30 years ago. That's a deep water fish. It's not too big, by the way, and it goes very slowly. Lives about 150 years. Size is small. Diet is from the bottom, mostly it's from the bottom. Reproductive age, look at that, 25 to 30 years old. So if you're depleting them now, they're catching a lot of orange roughy. You're depleting the population. And nobody knows because it's so deep. And eventually what you're going to have is, when you do fishing down the food web, there's not going to be anything. You're going to have blooms because there's no control of them. For instance, in jellyfish. And we can see here, all of this is full of jellyfish. There's no fish in here. Because now you change the ecosystem. It's not the same as it was before. It's called a phase shift. I'm going to talk about it later. A perfect example of overfishing was done here. It was done in the United States. There was the cod population that collapsed in Newfoundland. It's a famous story because this cod population, the cod fisheries was a very established profession in that area. About, it says that about 40,000 people were living off of it. And you can see that the amount of fishing was relatively stable. There was an increase at peak in around the 1970s, and a huge crush in the 1990s. A huge one, because there are too many people were harvesting. This is over exploitation. And you can see from what I know, the population is still not just starting to recuperate. So it's terrible. From a point of view of collapsing cod fisheries, about 40,000 people lost their job. Just imagine that. Just the fishing, overfishing. So probably, I just want to know, you all know about the tragedy of the commons? Because there's a clip, I can show it to you. I need to know if you know it. Yes, wonderful.
Yeah, we know it.
Okay, so Garrett Harding, he invented this idea about tragedy of the commons, and the example he used, other than the army, was the use of fisheries. That was like his perfect example. And it's exactly it, because the sea is an open sea and it's shared by everyone. So it's a communal ownership. And everyone can go and fish. And the tragedy of the common is that eventually everyone will fish to how much I can actually fish until there's no fishing around, no fish around. I'm going to explain to you this in overfishing and well, let's see a little bit of overfishing first of all. Well, the implications, I would say the implications of overfishing with marine ecosystem, we talked about it, is reduction, change in the species composition, reduction in the average catch size, change in the size structure of population. And we'll change also the bottom and all the organisms that live off of them. The food webs can be changed dramatically. So some of the people, I'm not going to tell you about this. This is actually boring. It's catchers, actually what they do. I'm going to go to this one. Hopefully we'll finish before time. We'll have time. So the whole idea about trying to do it smart is doing what they call sustainable exploitation. Basically, that you're going to have some kind of continuation or some sustainable yield, what they call maximum sustainable yield. And how do you decide what is the maximum amount of fish you can actually catch without letting the population collapse? It all comes eventually to the ecology and the life history of the organisms. You know that there's birth of organism and eventually dies. There's birth, and well, when birth and death meet, this is basically where you have the carrying capacity of how much organism can be sustained in one place. And the reason why you have death, or increase in death or decrease in birth, is because there's a certain amount of resources found in one area. Now, the idea about maximum sustainable yield is to find the largest yield or catch that you can find, or you can take, and without depleting the population for an indefinite period of time. Now, the catch is about this is that you need to have it sustainable, that you can catch and take out, and nothing basically will change the local population. So it depends on the population size, obviously, and it takes time. And this is, you probably know this from, this is a classical logistical curve of population. When the resources are increasing, and you have an increase in the population size, and eventually, when the resources are depleting, eventually you'll reach the carrying capacity. Now, the idea about this is that it's actually divided in this inflection point. That here you have an increase, very much like we have in the corona right now. And it reaches a point, and this is the highest degree, and it's going fast. From this point on, it will slow down. So from a point of view, if I look at it, and I go from here to here, from here to here, and from here to here, and I'm talking about now about what I can take out from yield. This is low yield. Anything which is in the before the increase will have a reduction and we don't use as much as yield as we wanted to. This area here, this is optimum for harvesting. And if you go here, the yield will reduce the amount of resources and will not get as much as you can. There's not going to be as much as replenishment. I'm going to change this. I'm going to show you this in another way. It's exactly the same thing. Here, this is the inflection point. I'm just going to do this because they show it differently in a second. And here, the sustainable yield. This is the size of the population. In small size population, you don't get enough yield. Here, you get a lot of yield. And from this point on, there's going to be a reduction in the amount of yield. Now, where do we fish? So the best thing to do for us is basically to be on the spot right here. So if we don't get too much fish out, we don't get not enough. So from an economical point of view, it doesn't work very much like we're doing it over here. So this is exactly the same curve that we just mentioned. Here we call it fishing effort, but it can be fishing effort, can be cost, can be anything that you want basically. And here's the yield. And you can see basically for a fisherman to go in, he has the fishing, sorry, this is the fishing effort, this is the cost. Okay, I'm sorry. This is the cost. And you can see that as long as he's making more money, so the cost is anything below, as long as he's making more here than here, it's good for him to actually go and the fisherman is making money. So he makes the most money just before the maximum sustainable yield. And when there is maximum sustainable yield, he's still making money, but not as much as if he was fishing at less effort. So he needs to increase the effort in order to get to the maximum sustainable yield. But what happens is if there is no regulation and a lot of people are going in, the fisherman will go and fish as long as he can get money. So everything here is money. So even though there's a lot of costs involved, he will still go out and fish in an area over here or here. Eventually, when the fishing cost will be as much as the effort that he's spending in the effort, meaning the cost and how much is spending for what he gets for the yield. If it's the same, then he's not making any money anymore. So he'll eventually go until he's not making money anymore. As long as he get fish, I'll go out and I'll fish, even if it's beyond the maximum sustainable yield. This is the tragedy of the commons. And the idea is, how do I make the people go and fish and stop right here without crossing this point, even though they have the potential to make more money? So this is most economic, this is least economic, but most probably will happen. And so these are the two extremes. So this is best, but not logical. This is most common, but probably won't happen. And obviously this will not happen most of the time. Now, if you do know the graph and you know the fishing mortality and you know the catch of the fish, you can go and find out what's the maximum sustainable yield. It's easy said, very difficult done, very difficult to make it. So it's very difficult to understand where is the maximum sustainable yield. The reason is we don't know the population size, we don't know the life history, we don't know how they reproduce, what's the sex ratio, what's the local conditions, what's the available resources, how they interact together. So in theory, everything looks really fine. But where is that position? Where is it the maximum sustainable yield? Where is the point right here where the resources are depleting? We don't know it. And this is probably the most difficult part, because for every fish it's different and their interaction is going to be also affecting one another. So it's very easy said, very difficult to be done. I don't know if I have time for this. We have about 5 minutes with for the session's ending, unfortunately. What we do know is that fish, when people fish, there's a lot of fish which they catch which is not relevant to what they actually need. It's called bycatch. And bycatch is anything which is not the targeted species. Basically, if this is coming out, probably they will take this as a target species, not necessarily, but a lot of these is bycatch. A lot of it is bycatch, especially the small fish don't be thrown back to the sea. Most fishermen don't use the bycatch to bring it back to the sea. It's all dead. So basically, 1 out of 4 is caught. 4 caught is bycatch, even though they're trying to target the right species. If we have time, I'm going to show you some pictures. Another bycatch that we have is turtles, especially on the big nets that we saw before. And what they have is you have turtles that get stuck in them, and eventually they need to go and breed. If they don't have the ability to breed, they will die. You can see them here. They've been all caught on fishing net. And what they made up is called the TED, the turtle excluder device. And you can see it here working. You can see this is they're trying to see how it works. Basically, the turtle will go in and it reaches the barrier, Now, he's strong enough to move the barrier out of the way and swim out, but most fish will not be able to, and they're going to go all the way to the end and where they're being collected. So this is one way of trying to understand, to deal with bycatch. Cetaceans do have a similar problem, and obviously seabirds. So I'm going to go to the solution. If you get caught, I'm going to re-sign you again. I'm really, really sorry. And then we're going to talk, maybe I'm going to steal a few minutes for you to see if this works for you for double sessions, or we should make it a single one. So the solution is probably aquaculture. You can see mariculture here. They grow in fish nets. We mentioned this before. Over 50% of what we have is aquaculture. There's various ways of growing fish in the water. You can see here a submerged, this like this one. This is submerged fish cage that can be done if the conditions are not very good. You can lower it down until the storm is going to pass, and then you can bring it up and work on it. It's closed so the fish don't go out. You have these really, really interesting balls that basically are doing the similar thing, and they just move out, and there's a GPS on them, and they just travel around the water, and you know where they are, so you come and pick them up from time to time and change the amount of fish inside. And it's really, really nice because it doesn't reflect too much on the environment. Because the environment, when you grow a lot of aquaculture, it becomes very, very difficult, especially because you have a lot of fish waste coming to the bottom. A lot of fish can escape. There's diseases. It brings predators, becomes some escape. Many people using drugs and chemicals that go into the environment. And these are the major resources for having some environmental impacts of aquaculture. So there's not only good, there's also bad food. This is how the bottom looks like, just big ooze, by the way. Really terrible. There is a solution to that. You can put, for instance, okay, just take a look. Think about how much ooze you can find in this place like this. Most of the fish cages are found in places where the water current is relatively small, because then it's more protected. So this is exactly how it looks like. I wouldn't like to go diving in this area, and think about fish that you eat in an area like this. It's all polluted. Look at the color of the water. It's not blue at all. So there is a solution to that. You can have fish that work underwater. You can have organisms that eat particulate matter. You can have mollusks that clean the water itself. You can have algae that clean the fish. Look, get this going right. You can see here algae cleaning the dissolved organic matter, and everything can be produced as byproducts for mariculture. Nonetheless, it's not very common, actually quite rare, that people use these kind of things. I'm going to skip this. I'm going to pretty much finish with this. The idea of future fishing is probably create marine protected areas to reduce the amount of fisheries, educate fishermen, regulate the fishing efforts and actions, which is very, very, very difficult, and study fish populations. And people are trying all the time. And trying to understand the relationship between physical factors and how fish production is done, and